Hi, my name is Alex Nasser, and today I will be presenting on John Snow and the 1854 London outbreak of cholera. The relevance of epidemiology is still useful today, just as it was back in the 1850s when John Snow started to use science and the power of deduction. John Snow, also known as the father of modern epidemiology, was a physician turned researcher. He survived multiple outbreaks of cholera in London when he started thinking how deathly this disease was transmitted. One problem was that there was no waste treatment method in London. This was coupled with residents living in crammed, tight areas with little to no sanitation. Most thought that cholera was just a side effect from dirty air, but through reasoning and deduction, Snow traced the problem of cholera back to a single source. Snow had theorized that cholera was not airborne, rather transmitted via dirty water. He started studying water supply some 5 years before the massive outbreak of 1854. In his journal publication in the British Medical Journal, he found that cholera was prevalent up to 3.5 times more in houses with dirty water. Water in London was supplied by 2 water companies, and Snow goes on to say that it's not just a coincidence that certain areas have a higher occurrence of cholera. Now, 150 years after the removal of the Broad Street pump, Nigel Paneth looks at the key ideas that we can take away from Snow's deducing and apply them in today's sciences. In Paneth's article, he states that the key to any epidemiologist's disease is to understand its mode of communication. Snow went on to visit each home, 658 to be exact, that had a case of cholera and studied what pump they got their water supply from as well as where they were located. Though he faced problems such as insufficient data and missing records, his findings were still a case that could be presented to a general public. During his publication, especially in the previous journal that Snow published in the British Medical Journal, his findings were largely not accepted by anyone in London. It took major convincing before the Broad Street pump handle was finally removed. This brings us to my area of research where I use ArcGIS and use point density, mean center, and directional distribution to find areas of deaths are located. Coupled with this, I analyze trade areas to see what impacts they have on death distribution. Through zonal statistics, I arrived at my final map that displays where the mean number of deaths are located per trade area. And just to be clear, the research area is 1854 Soho, London. As you can see from my model, we started with overall cholera deaths and through the different GIS tools, found 3 layers that were then overlaid to create the map, which I will show in a few slides. The density of cholera deaths is shown in red, with the darker red showing us where a higher or more density of deaths are found from cholera. The mean center of deaths is highlighted in green. This considers density and shows the location where the direct center of deaths is. The standard deviational ellipse is circled in purple. This tells us the general area where the most deaths were found. The mean center of deaths and the high density of deaths are centered in the same area from the previous 2 slides. This is the map that you get when you combine the 3 previous tools. As you can see, the mean center of deaths links right up to where the highest density of deaths is located, and encircling those 2 tools is the standard deviational ellipse. Pump data was also used. This map shows us where each individual pump is located. From the previous slides, see if you can hypothesize which pump is the problem. The trade areas are distribution points of each pump. If citizen A is in area 1, they will go to the closest pump to gain access to water. There becomes a certain point where one pump is closer to citizen A than another, and this is where the borders are drawn. I overlaid this data with the locations of the pumps so that we can see trade areas and more effectively pump locations. This brings us to our final map that shows what the mean number of deaths per trade area are. From our last 2 slides, we saw that the mean center and density of deaths was in the center near the dark of red area mean number of deaths by trade area. Also included in this map is the Broad Street pump. If you guessed right, which pump was the one of most concern? It was long after his time, but this is what Snow would have done using GIS to find areas of most concern. In conclusion, the highest density of cholera deaths was found in areas near the Broad Street pump. This was a pump that was in the center of the mean center and the high density of deaths. We used GIS to find the susceptible areas of cholera, which means that if you received your water from the Broad Street pump, you had a high chance of getting cholera. The Broad Street pump handle was, after careful studies, the handle that Snow pushed to have removed because the spread of cholera was becoming far too fast. Though Snow didn't necessarily end cholera in the Soho area of London, his study methods are a major factor how he figured out the roots of the issue and how we are still able to use those methods in science today. Modern cholera is still an epidemic that lingers today in the 21st century. I found a peer-reviewed journal article that illustrates the key factors of a severe cholera outbreak following floods in a northern district of Bengal. D. Sir et al. Found that lack of clean water, overcrowding, insufficient understanding of personal and domestic hygiene, nutritional deficiency, and overall poor sanitation are the major contributing factors for the spread of the diarrhenic enteropathogens and appearance of epidemic diarrheal diseases. What is coincident is that these are the same factors that killed so many people in the 1854 outbreak of London. What they didn't find some 150 years ago was the fact that cholera is still evolving and becoming resistant to antibiotics, a study subject for the future Jon Snow of our era. For areas of further research, we can turn our studies to bring in additional layers and GIS tools. Layers such as demographic information for the Soho area answers questions such as, does demographics have an effect on cholera vulnerability? We can map the economic distribution of Soho residents and find if there is a correlation between economic status and cholera vulnerability. We can also map what two water companies supplied water to individual pumps. This can give us insights and a deeper understanding of pump data. These are the data sources that I used during my research. My bibliography of peer-reviewed journal articles that I used in my research. And thank you for your time today.